Okay, so we're going to be looking at our sequential containers again today, which is the last kind of lecture on this subject. But we're going to be augmenting hugely with a discussion around passing functions as arguments. So this is kind of what we call an idiom or a pattern in programming. And it's a lot more than just the details of these containers today. It's a whole new way of managing making our code more reusable. So there's like a big message in our lecture today. I'll try to make it clear as we go through. But then we'll move on to our associative containers, maps, and sets starting on Thursday. So this is kind of our last lecture on all of this stuff here today. But there's some big messages. So Friday we'll have our lab from today, which is passing functions as actual arguments. We've never really passed a function as an argument before, so this is a new idea. And then we're going to jump into sets and loading stuff from a file. So we'll be getting back to file IO on Thursday, and therefore probably Program IZ Pro is going to become a lot more important, or Replit, one or the other. So if you have not signed up for one or the other, you'll still be able to get through it, but you might find it more engaging if you have one of those systems. So Tuesday, of course, is our homework, and it will include everything all the way back to lecture 8 through 11 today, not our lecture on Thursday. So that is kind of bigger than usual. So keep that in mind when you set aside time for that. And of course, your Connect 4. I'll have some extra hints on Connect 4 Thursday to kind of get people unstuck. Remember, use print statements. A cout inside of a loop can reveal amazing things. I was just doing that today. Today for myself, I had some pretty gnarly bugs on some stuff I was working on. So don't forget to throw those things out there. And I have all of our links in Canvas. So not just the Replit links, but we have our Program IZ links as well. Okay. So heads up, we got our midterm coming in 2 weeks and then spring break. So that's good and bad. We'll have a very comprehensive review on the previous Tuesday or the Tuesday right before that, and you'll have a practice exam. So it's all about retention and pattern recognition. So try to give you lots of opportunities. I know you guys are really busy with your other classes. So this will, of course, be open book, no AI, with all the trimmings, and it'll be based on quizzes 1 through 4. So you won't be really surprised by anything in theory if you've done a couple of the tries on each of your quizzes. And you are welcome to go back and or take your unused quiz tries before the midterm as a form of practice, but I will have to reset your score to your on-time score from when that particular quiz was due. So Canvas doesn't really have a system that makes this easy, so I got to go back and reset your grade. So please just be aware of that if you decide you want to do that. There will be some essay questions on there. I might change this. I will give you lots of heads up on that. They might be a little bit more meatier than our usual questions, but I will let you know about that with plenty of time, and you'll see it on the practice test as well if it ends up representing a large part of your grade. Okay, so today we're going to do a quick review on what we saw recently. And then we're going to jump into range-based for loops, which are a really great, fast, easy way to type a for loop. It's probably the best way to do a for loop in C++. And in some ways, it's even less typing than in Python. So we want to understand these things, and we want to understand kind of where we might have some bugs with them if we're not careful. Okay. A lot of times we will use this ampersand, which does get used for taking the address of something, but it can also be used as something called a reference and const. So we'll be reviewing the concept of references and why const, which is a little bit of an advanced topic, but we'll be pulling that in. And then we'll get to our functions as arguments, which is really cool, but a little mysterious if you haven't seen it before, okay? And we will try out those functions as arguments on our list and our forward list containers which we kind of saw briefly last time when we were doing our deck of cards in our last lecture. Okay. So that should get us to the end, and we'll look at a couple of things from the algorithms library. We don't use it too often, but for example, if I had this idea of a conveyor belt, so think of a list object as a linked list of things. It's kind of like a conveyor belt. And I have this robot, and I want it to look at everything individually. And if something is defective, then the remove if function is going to take it off the conveyor belt. So remove if is a function that's been written a long time ago, but we could write a is defective function and pass it into the remove if. So that now the remove if is using brand new code that it's never seen before, passed in a sense, as one of its arguments. So that's the model we're going to look at today. That's sort of passing functions into other functions that have been around for years and years and years. Super, super powerful pattern. And many modern languages support that kind of a thing. Okay. So let's just refresh a few concepts from last time. Kind of keep in mind that when you're dealing with classes, you pretty much have methods and data members. Okay. And so your data members are always there for you once you're inside of a method. So if you're writing the code for a method and you've kind of done it out of class properly or however inside of the class, you can just say the name of the data member at any time, okay? And those data members are, of course, either public or private. So we just got to keep in mind when we're dealing with a class, especially in homework, go back and review what your data member names are so that, they're kind of in the front of mind. And definitely don't create mirror copies of them inside of other methods, because then you just will never really get around to initializing them, okay? So these are kind of all the key parts. I know most of us are pretty familiar with these things already. And we'll kind of just continue to, explore more and more models of this as we go forward. Okay. So always our constructor must be public. So we always so far have put it in the public area. Okay. Now, again, let's take a look at our sequential containers just briefly. So these are things that collect things, and we more or less control the order in which those things get collected. It's obviously the order in which we push them in, either the front or the back. And some things like our list and forward list are just linked lists, and so they don't have random access through our square brackets, okay? And then that weird semi-modern array thing that we looked at. And of course, the string, which we've been using for a very, very, very long time, okay? And thank goodness for the string, because without it, all we used to have in C++ was arrays of characters and some other things called const string pointers. And that's from some pretty rough stuff. So the string class is really, really helpful. Remember, the key thing here is that templates allow us to do more than we just might have realized. In addition to just pouring in some type for a copy paste operation, we can also pour in an integer value. So templates are really a preprocessor that does a lot of copy pasting. It's really a fancy copy paste machine. So we're going to see more and more interesting ways in which templates have things poured into them that we might not have realized would actually open up some really powerful doors. Okay, so we'll see more of that as we kind of go forward in time. But that's a nice new one that kind of expands our understanding of things. Now, we'll see today that as long with the usual methods and lists, and we saw a few of these last time, we had push back and pop back, push front, pop front, and we lost some of these other things, okay? We're going to use the dot sort today for our lists, because the sort is a really fun module that teaches us some new tricks, or it's a fun method rather in the list class allocation, or the list class itself. So we'll be looking at that, okay? A little more in our lecture. Okay, so, but let's look at range-based for loops. So range-based for loops is a fancy name for a really quick and short way to pull each item out of the vector. Now, because C++ is a copy-centric language, that item variable there is kind of like for, get me the next thing from the vector, okay? But it's a copy of that thing by default. So item is a copy of the one and a copy of the two. It's not a reference to that particular item, okay? Which in a lot of times is not really an issue. So if I'm just printing something, that's okay. It's like, hey, I want to get the next thing and the next thing and the next thing. And the auto is just a very quick way of saving us from having to write vector template int. So auto says, hey, what are you? Oh, you're a vector of integers. Okay, now I know that I'm an integer. So really, this is an integer right here, okay? But auto figures that out because it looks at this and says, okay, the compiler really is the one that's doing the work. It's like, well, I know vec is a vector of integers, therefore that's got to be an integer, and now we have less bugs, okay? So, but that's what we call a range-based for loop. Notice there's no I there. There's no counting. We don't know offhand what item we're on, the first, the second, or the third. All we know is what the item is at every stage. And you can call that item thing anything you want. It's just a variable name, so you could call it foo or thing or item or integer or num or whatever. So that's just another variable part of the for loop. But it is the thing, not the index of the thing. So instead of where we usually have a for loop with I or X that represents the position, now we got the actual thing, okay? So all of our containers support this: vector, double-ended queue, list, forward list, array, strings, and even our old-fashioned, the array that we have used before, right? The C array, okay? That's pretty impressive. So if I say int A5, right? So that exclamation point is for emotion, not like code. So I can use a range-based for loop on this thing. That's pretty cool. So it is a solution for all kinds of collections. And so I tend to use it a lot when I don't care about the index of what the item is that I'm pulling out. I just want to get the next thing and the next thing and the next thing. Okay. So feel free to dig into that. Looks like I accidentally put the wrong link there. There was supposed to be a Program IZ link there, but you can kind of mock that up pretty easily. Now, we said this copies by default. So what does that mean? Let's actually prove that this is a copy. So if I say item equals 999, what are we really doing? Well, by default, we're just sort of changing a local variable called item from whatever it was, 1 to 999, but that's not changing our vec. So if I print that back out again from position 0 or anything, it's still going to be whatever it was, right? So we're not changing a copy because there's no connection between this thing and this or this or this, right? That's by default. But we can change that behavior with references, okay? So by default, C++ tends to be a copy-centric language. Whenever in doubt, probably it's copying something, okay? So, but let's change that using references. So I'm going to say auto ampersand item. So what I'm saying is, hey, when you pull this thing out, link it to that. And when you pull the next one out, link it to that and link it to that. And now I got a live wire connection to the actual item. So when I say item equals 999, now I am in fact altering the contents of the vector. So that reference is super powerful, okay? And we could easily just put int in here, right, instead of auto. So to not confuse things unnecessarily, we could have just explicitly said int, okay? So int ampersand item colon vector. Now, if I print out any one of those things, it is going to have modified that vector. So you kind of get to choose when you're doing your range-based for loop, whether you're planning on using that information to change it or not. Many bugs happen right here. If we forget the reference, then and we feel really good about making a change, like item equals item plus 1, and then we realize nothing changed, right? So why didn't it happen, right? So that's why we got to get that ampersand in there, okay? If we want it to change. Now back here, it's probably worth realizing that this is kind of a very inefficient thing to do if we're just printing something out. Actually, let me go all the way back here, right? So if I'm just printing out item here, I'm getting a copy and a copy and a copy, and that's actually slowing things down. Making copies is not free. So if we're just really printing something out and we really don't intend to change it, it's a little bit of a bummer that we have to pay this cost for making these silly copies, right? So, and we'll see in a moment that there's a way around that. So here was us not changing anything, right? Because it's a copy. Here's us on the next slide using a reference so that we can change it, assuming that's something that we wanted to do. So the reference allows us to do that. Let's first just warm up on that, right? Let's see if we can double all of the values from the original array up here by using one of these range-based for loops, right? So we want to actually make a change. So let's take a look inside of this thing and see if I can do this without losing my screen here and not blinding anybody. Okay, so here's my kind of code. I'll make this nice and big so we can all see it. Okay, so I'm just going to say fill array, and I'm just going to do it a vector of it. I'll do array. So I'll say array, array. We're just trying to help ourselves retain some of this. I'll do 4 array values. AI for array of int equals semicolon 1, 2, 3, 4. Okay, like so. Okay, and then I'll just do it down here so we can see it a little better. For auto item of AI, right? Okay. And if I say item times equals 2, that's like saying item equals item times 2, right? And then I want to print that thing out. Let me indent that so it's nice and clean. And I can use this for printing too, for auto item of AI. I'll just skip the curly braces this time. See out item. Okay. EMDL. Okay. So let's see what happens if we run that thing. Okay. I hate when I got that. So I got you. I got you. There's one more down here. So I'm actually okay. So I don't need that. Okay. So I got 1, 2, 3, 4. It didn't get doubled, right? Did not get doubled because that's a copy. But now if I put that guy in there, run it again, now we get everything doubled. Okay. So that's the key difference there. And you can put a space in there if you like, but it just sort of links that piece of data over there. Okay. Now, what happens if we make this a const? So people do this, and when you first see this, you're like, wait, if the whole point of adding an ampersand is so that we can change it, why would you add a const and an ampersand to the same piece of code? Well, here's why. So here we plan on changing it, right? We're planning on changing it. And we're willing to pay a little bit of a risk because we know that we're going to change it. But down here, I don't want anything changed, right? And I want it to go as fast as possible. So I'm going to say const auto ampersand item. So in other words, don't make a copy, but protect me so I don't accidentally change this in the printing process. So if I was doing a million of these things, const auto ampersand is a way of speeding up this for loop without making, so we're not making copies, but also preventing me from changing it. So notice I can't say item increment increment. So watch what the compiler does. If I try to change that item, the compiler is going to say, hey, that's a read-only thing. You can't change that. Okay. So we get to choose, and this is a very small performance hit for 4 things, almost unmeasurable. But for 40 million things, it really, really matters. Or for a video game or for a Chrome browser, it matters a lot. So we want to be conscious of when we're getting a editable item versus a const fast item. Okay. So if you see me saying const ampersand, it's just my way of saying I want that thing to go fast, but I don't want to accidentally change it. Okay. And there's nothing wrong. I'm not going to mark you off if you leave that const off of there, but you just might be interested to know because when you look on the internet, you're going to see that all over the place. Const auto ampersand or const int ampersand. Okay. So here's our const solution, right? So we've added that to our final print loop, but not our modify loop. Okay. Questions on that one? Okay. So keep that in mind, and we'll come back to that for sure. All right, so it's out of ways, but we're going to use the jigsaw puzzle, homework, and file streams together. So by the time we get to homework 5, we are for sure going to need Pro and Replit. So keep that in mind, or VS Code, which is perfectly fine. But let's just review some basics on file stuff, because I know some of us have not used that in a while. So if I have a file name that is words.txt, I'm going to need a variable of type ifstream. So ifstream is an input file. So what we're saying here is we're planning on reading things from this file, not writing to this file. So I got a temporary word, and I can check to see if the file is open, or sorry, not checking. I can literally open the file, right? So this name, not to be confused with, that's the file name, goes in here. This is like a fishing pole. We're yanking fish out of the ocean in, all right? So that's our file pointer, okay? And now we can do this. While file, load something from there, grab a fish, put it in the word, print the word out, okay? So while we're able to grab another word, keep going, okay? That's a really clean way to just pull data out of a file, assuming that the data file has blank spaces, or we say white space between the words, okay? Tab, or a new line character, or an entire blank line, okay? So that's a really great approach, okay? So that's gonna let us troll through that file pretty quickly. And then of course we want to close that file at the end, okay? So for those of us who haven't seen that in a while, that's kind of new. Now, this is Program IZ Pro link here. So for those of you who want to give it a try, you can, and we can use our handy range-based for loop for this. So I'm not going to go through all of the code here because, come on, baby, you can do it. You know you're there. You know you're there. There we go. So I won't change mine because then it changes it for everybody. But notice that I'm loading from some data file. That has to be there in Program IZ Pro, okay? So, and then the name is the name of my fishing pole, right? My file pointer that's pulling stuff out of this particular file once I open it. Gonna need a temporary word. And hey, now we have a place to put our words, right? So we're gonna use our forward list, which is a singly linked list with strings, okay? So we want to read from that file. I'll give you some solution code now so you guys can work on that yourself. Okay. And I know if you've only got online Program IZ here, you're probably stuck for the moment, but we'll get you a workaround here in a second. But here's our open file. And then while we can read a word, keep pushing it onto our words list. And then we can use our very concise, and we could say const auto ampersand W, and then cout W, and all of that would work pretty nicely, okay? So the really cool thing about this range-based for loop is it works for every container. It's just your brain just goes, I don't even need to think about whether I'm using a vector, a string, whatever. It's just use that for auto W colon words thing, right? And we're good to go, okay? So that's quick review on file reading, okay? Notice we're pushing front because we have a forward list. So if all of you remember your linked list where you had to push the head, push at the head, push at the head, push at the head, that's what's happening in this container. Forward list is just a singly linked list. So we can't efficiently push at the tail. We could go search for the tail and then add it, but that's not what the forward list is meant for in C++. Okay. Now we could do something a little differently. So, let's just review CIN. So that was the writing. Let's look at the reading. So we open a file for input. So ifstream is a different data type. Okay, I is for input. And then we have to have some data file out there. Yeah, we were just reading. Oh no, yeah, we were reading. So what are we doing here? I don't know why we're doing this again. Sorry, it'll come to me in just a second. Oh, I see. I'm just reminding you that CIN and infile are the same thing. Sorry, I lost track of where I was. So if you remember how to do CIN, you're halfway there to using our file read, okay? So sorry for that loss. Okay. Now, there are situations where we want to read an entire line. So let's say someone has chess moves in a game and it's like, king to queen 5. I don't know that language so well, but that's going to be a couple things on the same line separated by some spaces. And you don't know how many things are on that line. Maybe there's some comments. I don't know. You just want to read the whole line. So getLine will read the whole line from a file or common input, right? Until it gets to the end of line character, even if there's spaces between words. So that's a really handy feature. Get me a whole line until the end of line, and then do something with it, and then go around and do that again. So that, of course, works with different delimiters. We can say, hey, rather than going till the end of the line, just read until you get to whatever this is, right? So we can specify that directly, or we can use a variable for that. By default, it's going to go to a \n, right? That's our default getLine delimiting character. So if it works like this for CN, then it should work like this for some other file. Okay, so let me get my silly thing out of the way here so you can see what we're getting at there. Okay, so that is a really, really handy thing to know about. So here's us doing the same thing for a file. Open the file, get an entire line up until the end of line and print it out, or do whatever. Okay. Or, read until the end of a pound symbol or whatever, a comma, a semicolon, whatever the data file you're reading requires. Okay. Now that line itself could be comprised of other data you want to break up and do something with. Okay. So once you've read that line in, there may be other code you want to use to like break it apart and extract information from it. Okay. So, but this is the pattern that we would use to at least get that line of text in. And then, and notice it is a line of text, and then break it apart and do something interesting. Okay. Now, we're not going to do a lot of this in class because I just feel like this is, it's important work. Everybody's got to open files at some point in their life as a coder. But, this takes a while to get good at it. But this is a little clue for you just to remember. If you want to convert a line of text into almost like a file itself, that's called a string stream. So what I'm doing here, once I read in a line of text, I create a stream of characters, a string stream. I call it S, and I feed it this initial string. And now it's just like a file. So now I can say, set the delimiter, get not from a file, but from the string stream, until a delimiter, and put each thing in a word. So now we're getting a word and a word and a word and a word. Okay. So this is a really elegant way to create an inner loop where you're breaking down something you got from the first get line and using a second pass get line to sort of break it down further. Okay. Now we are not going to test you on getLine. We're not going to do that kind of work in this class, but I always feel bad if I leave it out because it is like a dark corner that you wouldn't otherwise know about. Trying to figure out how to read an open format line of text and then break that down can be a tricky thing. And getLine's a really clean and powerful way to do that. Okay? So we will talk about it, but we won't test you on that. Okay. So the string stream is a different animal, but it's just a great example of how we can kind of convert stuff into another form. Okay. Questions on that before I move us on? Okay, so we're just filling in a little dark corners around the outside here. Okay. And there's our words, right? Okay. Let's try this for parsing a CSV file. Okay. So here, I think this probably is a Program IZ Pro. Let me double check and see. I think we're into Pro on this one. No, we're not. So, so here's my trick for you folks who would prefer not to work in Program IZ Pro. Excuse me. So it's not a bad trick. So the online compiler lets us write files to the temp folder, okay? So notice that I've got a little function here called make file. So the first thing that happens in main is, and I'll come to that function in a second, I come up with a file name that I want to make, /temp/alpha.csv. So I want to create a CSV file for you in Program IZ so that you can read it. So I pass my file name into my makefile program, and then we just go get that file and read it. Okay, but let's take a look at what our makefile program is doing. Here's the file name. It's just a string. Okay, and then I make the information that I want to write to the file. And notice this little trick right here. This is a \n, right? \n, and let me delete that, right? But when I just hit the enter key, that's the same as a \n if I precede it with a slash. So if you kind of want to see it as it looks in the file, just do a /enter, /enter. And so now I have a string that has a bunch of end of line characters in it, \n essentially. And it kind of lays out nicely in my C++ code. And I'm just going to write that thing out. So I'm going to open. So this is me creating a file out pointer, and I'm calling its constructor directly. I'm not even using the .open method here, okay? So I'm just saying, hey, call the constructor on this OFStream class, create a variable called FOUT, and make it open that particular file, the file that we were given here, right? And then push some data out to it with an ENDL and close the file, okay? So this is a side trip that we're taking just for the online compiler, but it's a good review of how we can do some things with a function to quickly throw a file together. And again, the reason we're doing this is because, of course, online compiler doesn't support files officially, but we can get a quick file over there to demonstrate our reading capabilities, okay? So some of you might have jumped ahead. That's how we create the file. Now we want to parse the file. So let me help you with the code here, okay? So open the same file. And for those of you in Program IZ, it's going to be /temp/ that file name. Create a line, okay? Call the getLine function, convert it to a string stream, create a temporary word variable, and then for every comma in that string stream, call the getLine on the string stream. And now we are processing CSV files, okay, which, as many of you might know, is the global format for Excel spreadsheets, Google spreadsheets, whatever. And if you can read a CSV file, that opens the world to you in a pretty big way, right, as a coder, right? Because a lot of internships deal with data, and a lot of data is kind of in a not pretty format. So these two tricks will help you kind of process a lot of those data files, okay? Bit of a side trip, but a good review kind of for some of the stuff that we're going to need going forward, okay? So I'll just leave you with that for now. It is important that you be able to read files in this class, but this whole, more advanced breaking down of files, we won't challenge you so much on, okay? So let's switch gears a little bit and talk about our bigger topic of passing functions as arguments. So we're not saying call a function and give its result as the argument. We're saying literally give the function to another function so the other function can call that function. That's a crazy thing we haven't probably most of us dealt with before. So let's take a look at how we've written functions and arguments in the past. We've said, hey, this function is going to receive an integer, and then it's going to receive a reference to a Boolean. That means I can change it. Here's a pointer to a float. We've seen some of that. Here's a vector. Here's a reference to a list, right? There's another two-dimensional vector. So all these things we've kind of seen passed in his arguments. No big surprise. That thing is something else altogether. So that right there is a pointer to a function. The argument name is myfunc. It returns a Boolean and it takes one integer argument. Okay. So whatever you put in that slot when you call that function, it has to match that function signature. Okay. So it has to be some function that returns a Boolean and has one integer argument. The rest is up to you. As long as your function matches that, you can pass that function into my function. And I can then call that function, because I know whatever I give it is going to be an integer, and I know whatever I get back is going to be a Boolean. And this is some really cool stuff, and I'll show you why, okay? So that opens up a world of possibilities, because my function has never seen your code before. So here's an example. Let's say that we wanted to know if for some vector, every element in that vector passed some test, right? And our test for the moment is going to be whether that item is odd. So this is how I would do that. I would write this function called isItOdd, and if its modulo is equal to 0, I return true. And inside of my always true function, I'm going to loop through this thing. And this is a little tricky here, but this is part of the for, and this is part of the if. So if I hit even one thing that is not odd, then I leave immediately, okay? Because I know all things are not odd. So it's not all true. It's kind of failed the test. So this tests each individual item, and we're just saying, hey, are they all true or not? Well, nope, I found a bad one. Otherwise, if I get to the end, then I can return a true. So you're probably thinking, okay, we've seen this kind of thing before, right? But what if I don't really know whether I always want to test for is odd? What if I want to test for is even, right? So that would mean we got to write a different always true function, right? So I would need an always true odd, always true even, etc. Okay. But it would be far better if we could pass in the function to the always true, and it doesn't even know what the function is testing for. It just listens for a true or false return value. Okay. That's the really powerful pattern we're demonstrating here today, is if I could pass in a function here and then just call that function, this could be written 100 years ago, and we could write this today or tomorrow, right? And pass it in. And that is a truly powerful coding kind of pattern, okay? So here's like some pseudocode, right? So here's my second argument that matches the prototype for the function I want to call, right? Give me a number, I'll tell you whether it's odd or not, right? Boolean result, okay? But now we're going to pass that function in. So the name of the isOdd takes on the name of the myfunc argument name, okay? So I have two arguments. I have a v vector and I have a function that returns a Boolean that takes a integer argument, okay? Which is the function prototype for this up here, okay? So that's all we're really doing. And now we can come back, and when we call this thing in main, we just say, if always true, use this function. Notice there's no parentheses here. The parentheses are happening inside of here. I'm passing each item into the function and calling it from inside of here. This is really technically a pointer to a function. So I'm saying, hey, here's a pointer to a function you should use. Go ahead and use that, okay? And now I can easily pass in a different function pointer. So I'm reusing the always true code without modification and passing in any function, even something that hasn't been written yet, okay? This is a hugely ubiquitous pattern in cloud data processing and C++ code, because it just lets us reuse code. So we're going to find libraries that are seemingly very confusing at first glance. But once we recognize this pattern, it's like, oh, you're opening a door for me to pass in some code of my own. and you've already written maybe the messy code. And I'm just providing a little nugget of logic that gets called at this point, okay? And that's some really cool stuff, okay? So we're going to explore some stuff that's already been written that way here in our library, just to get familiar with the pattern. But just keep in mind that we're calling the is odd. We just passed in the pointer to the function in order to do that. Or we're calling the is even once we get into the function, okay? So that's the big takeaway, okay? It saves us code. We don't even know yet, like what kind of functions we might want to pass in. It's really, really cool, okay? And the algorithm library is just one library that uses this pattern over and over again. Really important algorithms like sorting, right? For those of you who took algorithms, Comp 220, you don't want to write another sorting algorithm. But what if you got to sort something that has never been sorted before, like some new class that you've created? How are you going to actually do that, right? So let's take a look at that exact situation. So both our lists and our forward list have a sort function in it, okay? So these are just some of the methods or functions, but methods that are inside of the list, right? And here's some methods that are inside of the sort. But what if we're sorting instances of cards in a card game like we were making in our last lecture, okay? How does it know how to sort a class it's never seen before? Well, this is where our passing of functions it comes to the rescue, okay? So let's look at sorting for lists, okay? So if I create a list like this, and feel free to code this up, this is not a lot of code. I can just say my list.sort, and now it's sorted, which is really great just by itself, okay? But it's going to be in ascending order, okay? So what if I wanted, and that's n log n, right? So for those of you who remember, right, that's our linear rhythmic, very fast sorting. So it's going to produce an ascending order. But what if I wanted in descending order? How do I change that to be descending order, okay? Or what if I wanted to sort evens on the left and odds on the right, right? That's a form of sorting. I could do that. Or, things divisible by 3 on the left and everything else on the right, okay? So that's where we want to actually do some sorting. And if I had a list like this with cards, well, we can't even sort these in ascending order, because how does the my sort know to look inside of each card instance to its potentially private data members, right? So all sorts of problems there, okay? So this is where this method comes in handy. Now, if we think about sorting, the only thing we need to do to sort is compare two items. If you remember your sorts, or you just remember even a bubble sort, we're going to compare the 9 and the 8 and swap the bigger one to the right, or the smaller one to the right, depending on what kind of sort we're doing. So it really comes down to the comparison of two things. Everything else is just sort of bookkeeping, right? So what do we want to do to enable sorting of any arbitrary class? We want to write a function that compares two things and returns true or false. Like, should you swap them or should you not swap them? Okay. And that's where we're going to apply this pattern to do that. So letters, really easy, numbers, really easy, but a class, something different. But let's start by just doing it with an integer. So we're going to write a function called myCompare, okay? And it's got two arguments, integer and integer, okay, which conveniently match this, okay? And then I want to call the sort, but pass in a pointer to a function. So the name of a function is essentially a pointer to the function. Notice we don't use any parentheses there, right? It's like, hey, here's the thing you're going to use to compare. How do we know that that's okay? We got to go look it up. We got to go to the documentation on sort and say, hey, what is the function signature you need in order for me to control you, okay? It's not like I just knew that out of the thin blue sky. I had to go look that up, okay? So here's our very simple myCompare function. If A is greater than B, return true, else false, okay? So that's going to create one type of sorting, okay? So when we run our mylist.sort, we're going to essentially get a call for every iteration of that comparison. So our function gets called for 1 and 2. And so the 1 comes in here and the 2 comes in here, and we return true or false. And then it moves over and the 2 comes in and that's compared to the 3 and we return true or false. Okay, oops. So interesting. I was sure I uploaded my slides. That's too bad. So that's really what we're going to do, right? So we're really just altering that order. So by changing this to a greater than or less than, we change effectively whether we're sorting in ascending or descending order. Okay. So essentially what's happening, as we saw before, is the my sort or my compare kind of ends up being called right in there, right? So this is pseudocode for sure, but this sort of iterator loop we saw last week is actually being used inside of these things, okay? So we're dereferencing the iterator and the thing next to it and calling our function to compare and exchanging it, right? So this is pseudocode, but that's basically what's going on inside of that sort, okay? And it's probably a merge sort or something like a quick sort, probably a merge sort actually, okay? So let's see if we can actually do this. And while you guys are working on this, I'm gonna go probably upload and update my slides. I must have loaded them into the wrong folder. But see if you can actually go ahead and write this thing. So we're gonna be, in this case, we're still in the online compiler here, but see if you can, so this is sorting in descending order, right? So see if you can actually finish this one. I think there's a to-do in here somewhere. What are we after? We're saying run it and then modify. Yeah. So notice that before we have 8, 9, 6, 7, right? Random order. Now we have descending order. Just modify this guy right here and see what you get. Okay. And then see if you can come up with something crazy like if, you know, A is, divisible evenly by 3, return true, right? See what happens to your algorithm for sorting. Come up with some crazy thing you want to do over there instead of just a simple comparison, okay? So let me give you that for a moment and let me just go look and see why my slides are not updated. Pretty sure I know. Just disappointing. Files, files, files. And I think there is a quiz question kind of related to crazy sorting like this. Like, hey, if it's modulo 3, put those things on the left kind of versus the right. Okay. Okay. Looks like I uploaded it today, so I am really quite surprised it's not quite, at least my recollection is it's. So here is my compare, okay? And there's a variety of things we could do here to change the behavior of our sorting, right? Check for modulo 0, check for not modulo 0, or modulo 2, etc. Okay. Make sure you don't put the parentheses on the my compare. So we're just handing over the function so that it gets called, right? Curious. Now, taking it up a notch, you might think, oh, well, I don't want to have to write a compare function for every single kind of container, integer, float, whatever, but that's easy, right? We saw how to do templates, right? So now watch this. So I've taken the int out and replaced it with an arbitrary type t, okay? So as long as I can compare A and B with this arbitrary type t, right? Then down below here, I pass in the my compare function pointer with its templated type. That's some crazy stuff because now I'm sorting on a compare for a templated type that's being passed into the function, okay? passed into the sort function. So what if that was a card instead of a double, right? So we would have to overload the comparison operator in the card class, but we've seen how to do that, right? So all of these patterns start reaping benefits like in a large scale. I can overload my stuff in my card class. Now I can templatize my compared. Now I can pass that as a function pointer. This is where advanced coding really starts to take off in C++ and start designing super powerful stuff with relatively little code. Okay. Let me let you guys finish that one here for just a second. Those are some like, wow. Those are wow moments for me anyway. Man, I can write less code. I love that. Questions? Okay. All right, let's look at a couple other things that are already shrink wrapped for us. So let's look at remove if. We're going to look at a couple of these. So we want to remove something from the list if something is true. Okay. Well, what is that thing that's true? Well, I don't know. It's kind of depends on what little function we write. Okay. So remove if is a method for the list, and we can write the function that decides whether something should be removed. So my function is going to be called doRemove, and remove if is going to call my function if I pass my function into its method. Okay. So nobody really likes writing code to remove stuff from a list. It's kind of messy, but here's this really nice function, and we just have to decide whether or not to remove. Okay. So that's how we would call it. I'd say mylist.remove if pass in the qualifier, or that's that robot from our opening slide, right? It's like, should I remove this thing or not, right? Okay. So let's take a look at what that thing does. It gets passed some value, an integer from the list, and we look at it and go, I like it or I don't like it, one way or another. So let's say it's somewhat arbitrary. If it's a 2, I like it, or I don't like it, so remove it, right? So true, remove the 2, right? Otherwise, don't remove it. So then when we call this thing, right, it's going to just travel across this thing and do all of the dirty work for us, right? So it's going to take that out, whatever that means, and come back and process the whole thing eventually, okay? So these things aren't too hard once we sort of know what remove if wants. So we kind of have to go look up remove if and see what the function prototype is, right? So this is the function prototype we got to write. And so I wouldn't know it if I didn't go look it up. So we got to go look at that thing, okay? So that's what actually gets passed in, and that's what becomes the argument inside of the pseudocode here, okay? We're just like, hey, do you want to remove this ith item? Yes or no? Okay. Some magic happens over here and removes that thing. Okay. Yes. So removing already moved through the list? Yes. Yeah. So all of this pseudocode is presumably inside of the remove if. So we don't have to ever write any of that code. We just write the qualifier function that decides whether a particular thing should be removed. Okay. And we could templatize this too if we wanted to. If we wanted to make it super general, right? We could just make that a templatized function. Okay. So there's a few of these. Let's take a look at this one. So see if you can. So run this playground or the REPL and just see what it's removing, right? It should already work. And then write a doRemove function to return true if the argument is a multiple of 3. Just kind of experience what that does for you, right? And I'll jump into the code here. Whoops. And you can use the modulo for that. I think I probably hammered on that enough. Everybody knows, right? Well, let's just run it, see what we get. So here's what we had, right? So in the current situation, remove 2 isn't even really being passed the function. So, well, that's the remove, right? So we want to call remove if and pass in a qualifying function there. Okay, so you got a couple things you got to do and then print out that thing at the end, right? So we're already doing it with a simple remove, but we want you to do it with a remove if, okay? So the thing that we're writing, there's our do remove, okay? You give me a number and it's evenly divisible by 3, I'll give you a true, otherwise I'll give you a false, okay? And then I just do that. Oops. And then I got to do my for loop to see what I got as a result, right? It should get rid of the 3, the modulo 3s, okay? So in data processing, what happens in data processing is, removing bad data, right? Or filling in gaps, right? If we are looking at temperature data on weather underground that got collected from a bunch of sensors, and there's a value of 1,053, we probably want to average that, or throw that one out, or do something with that because it's probably a piece of bad data. Okay, so there's a lot of reasons why these little kind of remove if things get written, and the logic just changes, right? So we write the little logic piece. Okay, here's another one. Transform is a little more powerful, but maybe a little more confusing. So let's just kind of dig in a little bit. Remember that our ASCII code has large capital letters over here, a couple annoying special characters, and then our lowercase letters. Seems like they didn't even think about this when they put the ASCII table together, right? So the difference between these is 32. So to make something lowercase, when we did this in Comp 130, many of you might remember, it was tedious. It's like, oh, I got to loop through and do a math thing and then put the characters back. So all of that code is kind of really the same if we think about, the adding is the only part that's different, okay? Adding or subtracting. So we want to kind of use one of these transform functions to change something to upper and lower case. So if I create a function called force lower, so notice that it returns a character for the given character. So you give me a character, and if I can make it a lowercase, I will. Otherwise, I'll give you back what you gave me, okay? So this should all work, right? Because they're all uppercase, okay? So we got to write that, but the transformer says, and here's where our iterator intelligence comes in. Hey, I want you to go through the whole S1 from beginning to end and put the transform thing starting at the beginning. So basically overwrite this thing from beginning to end, starting from here, and use this function to decide how we overwrite it. So for every letter, pass the letter to my function and then replace from here on to here. This is very confusing. I definitely will admit. It's like, hey, wouldn't we just say do the whole thing? But this lets us section out pieces of it and maybe convert it and store it in different areas of S1. But we would very likely just sort of have the whole thing converting, in place, right? So that's us calling transform, right? To force that thing lower. So let's take a look at what that force lower looks like, right? Pretty straightforward. If C is in the range of capital A to capital Z, add 32. So we got to add 32 to convert it into a lowercase, okay? And I feel like I'm missing something there. I feel like there should be an else. um, yeah, I think there's a bug here. I think there should be an else here. That's kind of surprising. Else return C, right? So that's a oops on my part. That would actually be a pretty nasty bug, I think. So right, so we're just gonna write that, and then it's gonna take care of all this other stuff for us. Okay. So taking a look at, again, symbolically what happens in pseudocode, we're just saying, hey, what's at that particular iterator, we're going to Actually, it should be Q. Wow, here's another mistake, right? Q. What's at Q equals the function of what's at Q, okay? So I'll come back and I'll fix that one later, okay? And that's how we call it. And once again, I would never remember all of this. I'd have to go look this up, right? But it's the pattern that's important, understanding what it is we're actually doing. Then the documentation is a little more easy to understand. Okay. So I think we might have a practice problem on this. This is just ASCII, you know, this is the ASCII table all kind of put in one long continuous stream. So it's not a very great picture, but if you didn't remember your ASCII math, that's a little more information for you on why we do that, okay? So let's try this with a custom function, run it just to see that it's working with force lower, see if you can change the math to make it, or to write a force upper, like so copy, paste, and then modify to write the force upper, okay? And then pass that into the transform and see if you can force something into the capitals, okay? So let's see if this thing comes up okay, and I'll let you guys dig into it, right? So you can literally copy paste the force lower, create a force upper, and then down below, just sort of use that thing down here, right? And just compare the answers. Should work out pretty easily for you, okay? And if you ever go looking for a transform, it's in the algorithm library. So we got to actually load algorithms up top, right? So pound include algorithm, okay? It's not a huge library, but it's got some handy stuff in it. Okay, so we're just passing function pointers to. All right, one more, I think, for each, and then we'll get us into our lab here. So for each is like a for loop, and a lot of languages implement this, including a lot of like web tech languages, backend servers, front end. It's like, hey, we know how to write a really efficient for loop. You just tell us kind of what you want to do to each thing, okay? So if I have a vector and I want to only print the odd numbers from that, for example, so this is a little bit of a weird one. It's not returning anything, it's just doing something with each thing. So you give me the A and I will do something with it, okay? So we'll write that. So then we say, hey, from the begin iterator to the end iterator, call this function, okay? So these could be file names. Maybe you want to open a file name and, check for stuff, right? So you could do a for each begin end on some list of file names, right? And instead of printing odd, you write a lot more code that opens a file name and does some stuff, okay? So, but for the print odds, let's see if we can actually implement this one, okay? So this one we'll kind of do from scratch, okay? So take a look, see if there's any other stuff there. Let's jump into the code. And I think this will be our last one. So this is a lot for one day. So refresh. There we go. Okay. So we want to include, I think we said algorithms, right? So pound include algorithms there. I won't change this again because it's going to end up changing my, oh no, this is the online compiler, so I can do this. So we'll say pound include algorithms. Okay. Right. Okay. And here's our list. Odd values begin in. So we want to write a function here to print the odd values, okay? So our function prototype is going to be, we're going to have a void, and it's going to be print odds, right? And we're going to receive an integer, right? Integer, int, num, right? And we'll just say if num modulo 2 equals 1, std cout num, okay? And I'll add an extra comma after that. So, okay. And then down below, we should just be able to pass in the print odds, okay? I don't like that. Okay, no parentheses. Okay. So let's see what happens here. Oh, include algorithms. No such. I do this all the time. Sorry, folks. I already led you astray. No S. There we go. Okay, and there's our odds. Okay. When I first saw one of these, I thought this is the weirdest language I ever saw. I think I saw it in a web language called Ruby, and I thought, why not just a good old for loop, right? But now I understand, right? The for loop is already written for us. We're just sort of passing in the logic, key logic. Okay. Now, just so you know, you think, okay, and I'm still a little annoyed at C++ for how hard it is to make something upper or lowercase in modern, code. But it does turn out that they did anticipate this, but it's a very bizarre way of doing it with a double colon two lower. Okay. So two lower is something we can use. We won't go into what that is, but you can say two lower and two upper there instead of writing our own function. Okay. It's still really ugly. I can't believe that it's not an easier way to do that, but um, it's basically a character processing function, and we have to qualify where it's coming from with the double colon, but I won't go into why we got to use the double colon. It's kind of like std double colon, here's my function, right? But we're just leaving off the std. Okay. Question? Specific, like, do we have to include that? Or like which library? Oh, fair question. I think it might come from the string library, but I'd have to look and see if it comes from string or algorithms. Yeah, that's a fair question. I don't know if I know the answer to that off the top of my head. I'll check. Yeah. I think it'll probably work with the code, but you can find out pretty quickly by just dropping it in there instead of your two lower thing. Okay. Okay, so our lab today is not a lot of code at all. It's really only these two little functions, but I realize it's kind of convoluted. In other words, in main, you're going to look at main and go, what are we doing here, right? So I added a lot of comments to try to help you, but all we're trying to do is say, hey, if this is odd, then add it to this and return it. Okay, so this is a way that we accumulate an answer across a large volume of data. We write a small function where we are given the sum so far, and we have some conditions under which we're going to add that, right? So we're adding the number if num is odd, and then we are returning sum so far plus num, okay? Seems kind of weird, but this way we're getting a little more information. We're getting two arguments from this master function, right? So we're going to have a sum if odd and a sum if even, okay? And we can just test those real quick, right? So that's just our little tester function, okay? So this is me just showing you, this is how you want to verify that your function is working. But what we really want to do is use that sum if odd and sum if even inside of some other stuff, okay? So accumulate is the function we want to pass your sum if even and your sum if odd to. And it comes from a library called numeric, okay? So here, let's look at a couple examples. You can look that up if you want, okay? But we're going to pass in the begin and the end, followed by the initial accumulation value. So you want to start at 0, right? Because we haven't accumulated anything yet. So you're going to need to start with a 0 value and then pass in also the name of your function, okay? And it's like a bucket brigade. Your function will be given the sum so far. That's the accumulation. And you will add to it over time if you want to. So it's going to kind of look like this. Int evens equals accumulate, v vector begin, end, 0 to start. Here's the function that decides whether we add values to it. So we're collecting things according to the sum evens function. Okay. I think the odd, nope, the odd's not there. But so you'll need to add the call to accumulate for the odds. So we've given you the evens so you have a pattern. So it's not a lot of code. It's really maybe a half a dozen lines of code at most. So it's the pattern that we hope you are sort of getting comfortable with. Okay. Questions? Okay, so we'll call it quits on that. A lot of stuff. Thanks for hanging with it. And we'll see you on Thursday. Okay. Thanks, everybody.